in this section, we're going to be looking at using congruent triangles. This is where you're going to use you're going to prove two triangles congruent, and then from that, you're going to have parts that are congruent. This is actually corresponding congruent parts theorem. Sorry, I forgot the congruent portion of this. So if triangles are congruent, then their parts are congruent. So in order to use this theorem, you must prove that your two triangles are congruent. That is a key. And the reason why is because obviously if you think about if you're proving two triangles congruent with side, 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 for instance, you have shown that three sides are congruent. Therefore, the triangles are congruent. If the triangles are the exact same, then I can pull out then from that the angles are also congruent within that. But again, you must first prove that your two triangles are congruent using those different theorems that we've talked about. Sometimes your pictures will be overlapping, and so I just want to kind of give you an idea of what the overlapping angles and sides may look like. If you look at this first one here, your triangle FRK and your triangle of SPK, I can see that between the two triangles, they overlap angle K. But I'm not going to just say angle K. I'm going to be a little bit more specific because in the blue triangle, that angle is associated with angle FKR. And in the pink triangle, it is angle SKP. Okay, so sometimes it's easier to pull the two triangles apart. Sometimes it's not. It's just a personal preference. If you look at example 2 here, determine the reason why the two triangles would be congruent. This is basically the setup for your overlapping and setting it up later on the road for the corresponding parts. If I'm looking at this, my overlap, I can see triangle DCF and triangle EFC. My overlap is obviously the C and the F, but this might be easier to pull apart. So if I'm looking at this on the pink triangle, and then I should have drawn them a little further apart, my fault. But we can see on the pink triangle, DC is congruent to FE. And if you look at our given information, we know that DCF is congruent to EFC. Now, the overlap. I can see that CF here is overlapped. Therefore, it's congruent to itself. So you'd have your given information right in your proof. The second line would be that CF is congruent to FC. They're overlapping, so that would be reflexive. Then your two triangles are congruent. Well, looking at my markings here, this would be side angle side. Okay. Technically, it didn't ask you to write a proof, but just kind of thinking through, this is how that proof would go. Now, example 3. This is where we're going to use that corresponding parts theorem. We already know the given information and we know the proof, so we can go ahead and fill that info out. And if I'm looking at this, I can see that I'm proving sides congruent. So I know automatically that my reason is corresponding parts congruence theorem, CPCT. I know that automatically, like I said, because you're proving a part congruent. And if you're proving a part congruent, the line right above it has to be that the two triangles are congruent. So realistically, out of this 8-point proof, you should already know 5. Just by using that information, those context clues, in order to figure that out. Now, obviously, we can fill within, since we've been proving triangles congruent using our different theorems. Looking at this one, I can see that I have a reflexive, I have that overlapping, which is going to be MO to OM. And based on my two triangles, angle, angle, side. So the corresponding parts congruence theorem isn't really any different than what we've been doing. It's just an extra layer. And if you know that it's a part, then obviously you can use that corresponding parts congruence theorem. The other thing is the overlapping angles and sides. Sometimes it benefits to pull those apart and look at them separately. But generally, if you have that overlapping, we already know it's a reflexive. So just kind of looking through those things and adding that corresponding parts congruence theorem.